Hello, everyone. Here are some example problems finding the solubility of a salt from its solubility product, Ksp, and how to find Ksp if you're given the solubility of a salt. So for one, we're going to find the solubility of lead chloride. So lead chloride is a slightly soluble salt, PbCl2. And if you were to put solid lead chloride into pure water, you would get some formation of the lead 2 ion and 2 chloride anions. And so the equilibrium constant for this reaction, this is a special case of a solid salt dissolving into water. It's called a Ksp value. And so Ksp, like any other equilibrium constant, is products over reactants, except in this case, our only reactant is a solid, and so we omit it from the Ksp expression. So our products are lead 2+ and chloride minus, and because the stoichiometric coefficient of chloride is 2, chloride is squared in the Ksp equation. Now, if you look in a textbook or on the link provided in the pre-lab, you can get values for these for Ksp for these solubility product equilibrium constants. And for lead chloride, that value is 1.70 times 10 to the minus 5. And from this value, if we're given Ksp, we can find how much lead chloride will dissolve when we add it to water, right? So we can find the solubility of lead chloride. So to do this, we'll set up an ICE table. Remember, lead chloride's a solid, so we leave it out of this entirely. And we're starting with pure water. So initially we have no lead and we have no chloride. At equilibrium, we'll have made some amount of lead. I'm going to call that plus S for solubility. And for chloride, we'll have gained 2S because the stoichiometric coefficient of chloride is 2. So our equilibrium concentration of lead is S. Our equilibrium concentration of chloride is 2S. So now we can go ahead and plug those values into our Ksp equation. We get that Ksp is 1.70 times 10 to the minus 5. Pb2+ is S. Chloride is 2S. And as you rearrange this, make sure you take care to account for the fact that this 2 is also being squared. So this reduces to 4s cubed. And with a little more calculator work, we have solved for the solubility of lead chloride S, which is 0.0162 moles per liter. This is the solubility of lead chloride in water. The other example that we're going to work is how to find Ksp if you're given the solubility of a salt. So if you have the information that the solubility of silver iodide, AgI silver 1 iodide, is 9.23 times 10 to the minus 9 moles per liter. You have all the information you need to find the Ksp value for silver iodide. So once again, our starting place is to write out our chemical reaction of solid silver iodide being dissolved in water. We set up an ICE table. Once again, our salt is a solid, and so we don't need to include it. And again, our initial concentrations are both 0. In this case, it's nice and simple. Our change for both is plus S. So our equilibrium concentration of silver is S. Equilibrium concentration for iodide is also S. And Ksp is products over reactants, simply Ag plus times I minus. So Ksp is S times S. And since we know the solubility S is 9.23 times 10 to the minus 9 molar, right. Ksp is simply the solubility squared. So the Ksp of silver iodide is 8.52 times 10 to the minus 17.